All right, let's dive right into this. Welcome to our latest explainer, where we take complex source material and break it down into something you can really use and understand. Today, we are looking at an absolute masterclass in modern web development and digital product engineering. We aren't just looking at some weekend coding project here. We are exploring a fully realized, market-ready digital product called the Bkappi Tuner. If you've ever played a stringed instrument, you know that tuning is literally the first, most crucial step before you can even think about creating music. But honestly, finding a reliable, fast, and secure digital tuner can be a surprisingly frustrating experience. So today we're going to explore how one developer completely solved this headache using cutting-edge web technologies and why this actually matters a lot for the future of digital products.
Think about the last time you downloaded a tuning app to your phone. It probably asked you to create an account, pushed a bunch of intrusive ads in your face, demanded an active internet connection, and maybe even felt a little sluggish or laggy. When you're holding a guitar and just trying to get into the flow of practicing or performing, that kind of friction is a massive pain point. You just want something that works instantly, right? You want an app that listens to your instrument in real time without compromising your privacy or draining your battery with weird background processes. Well, that is exactly the core user problem the Bkappi Tuner sets out to solve.
So the absolutely crucial point here is this number, 100%. The Bkappi Tuner runs 100% in your browser, completely locally on your device. And because it's running locally, it is 100% private. Let me repeat that because it's important. Zero audio data is ever stored, transmitted, or uploaded to any external servers. In an era where literally every app seems to want to harvest your data, delivering a tool that processes your microphone input entirely on the client side is a massive competitive advantage. It builds instant trust with the user.
What we're looking at isn't a heavy native app you have to go hunt down in an app store. It's a web application accessible via a simple URL. Notice that premium, minimalist design. It utilizes a really modern glass morphism aesthetic, complete with native dark and light modes. It's super clean. There are zero ads cluttering the interface, and it delivers these beautiful fluid micro-animations. It feels exactly like a high-end native application, but it requires absolutely no installation and zero registration. You open the page and you tune. That's the whole shebang.
Now, these technical achievements directly translate into immense value for the end user. By leveraging the Web Audio API, the tuner captures the microphone signal and performs some pretty complex digital audio processing entirely within the browser itself. This is what allows for those buttery smooth 60 frames per second transitions. It also means that once you load the page, it has full offline support. You could literally be in a basement practice room with absolutely zero cell service or Wi-Fi, and this tuner is going to work flawlessly. It completely removes the friction between wanting to play your instrument and actually being ready to play.
Let's talk about exactly who this was built for. While it does feature an advanced chromatic detection mode that can identify any of the 12 musical notes across multiple octaves, we're talking from C0 all the way up to B8, it is heavily optimized for stringed instruments. It features dedicated, highly reactive profiles for acoustic guitar, electric guitar, and bass. When a musician selects one of these profiles, the interface doesn't just show the letter of the note, it visually indicates which physical string on their specific instrument is closest to the note they're playing. It's a really thoughtful design choice that caters directly to the needs of its target audience, ensuring zero latency precision for a totally seamless tuning experience.
Section 1. Under the hood, the audio processing engine. So, delivering a sleek interface is one thing, right? But a tuner is really only as good as its underlying math. We're going to look under the hood at the digital signal processing, or DSP, architecture. This is exactly what separates a frustrating jittery tuner from a professional-grade tool. To solve the incredibly common issues of excessive sensitivity and abrupt frequency fluctuations, which happen naturally when you pluck a string and get all those secondary harmonics, the developer engineered a brilliant three-part client-side digital processing mechanism. It's basically a pipeline designed to take raw, messy audio data and turn it into a perfectly stable visual output. Let's break down these 3 steps.
Step 1 is the RMS amplitude gate. RMS stands for root mean square. In simple terms, this algorithm calculates the actual physical energy of the sound hitting your microphone. Instead of trying to tune the sound of a truck driving by outside or the hum of your air conditioner, the RMS gate basically acts like a bouncer at a club. It filters out the ambient noise. It maps the audio levels to give the user immediate visual feedback, reporting states like no signal, weak signal, or good signal. This ensures the tuner only ever activates when you are actually playing your instrument with enough volume.
Next up is the exponential moving average, or EMA. You can think of this as a digital shock absorber for the tuner's virtual needle. If you've ever used a bad tuning app, you've seen the needle twitch and jump around erratically. The EMA applies a low-pass frequency filter that smooths out those micro-fluctuations, giving the needle real physics-based damping. But here is the real genius part. If the algorithm detects a frequency jump greater than 8%, which basically means the musician has actually turned the tuning peg or played a completely different string, the filter resets instantly, so it smooths out the noise but remains incredibly responsive at 60 frames per second when a real change occurs.
The final step in the audio engine is statistical mode filtering. The application doesn't just look at the exact millisecond of audio it's receiving right now, it actually keeps the last 12 readings in a circular history queue. It then analyzes this recent history to find the statistical mode, basically the note that is appearing most frequently. By looking at the recent past, it completely filters out transient spikes or unstable harmonics that happen the exact moment a guitar pick strikes a string. The user benefit here? A completely stable, flicker-free visual pointer that you can actually trust.
All of that heavy processing delivers incredible mathematical precision. The physics-based analog meter on the screen represents a range from -50 to +50 cents, and the app maps these cents dynamically. If you're within -1 to +1 cent of the target frequency, boom, it locks in as in tune. It gives the user really nuanced feedback too. Near in tune, near sharp, very flat, allowing for microscopic adjustments. It's incredibly rigorous engineering translated into a totally intuitive user interface.
Section 2. The Modern Tech Stack.
So how exactly do you build a heavy-duty audio processing engine that runs instantly in a web browser? Well, you have to select a very specific, very modern technology stack. The developer didn't just throw this together randomly. They used React 19 and TypeScript for a robust, type-safe core, packaged with Vite for lightning-fast build times. They used Redux Toolkit for managing structural settings alongside React's local state to handle that high-frequency 60 FPS audio stream without completely crashing the browser. Styling is handled elegantly by Tailwind CSS version 3, but the real star of the show here is the integration of a library called Pitchy, which provides highly optimized fast Fourier transform or FFT pitch detection. And to make it a truly global product, it uses IHI Next for full offline internationalization, seamlessly supporting both English and Brazilian Portuguese.
Section 3. The Developer, Bkappi. To fully understand why this product is engineered with such rigorous, almost physical stability, we kind of have to look at the creator behind the project. The Bkappi Tuner was created by Bkappi, a full-stack developer and systems analyst based in Rio Grande do Sul, Brazil. What makes this context so fascinating to me is Bruno's background. He actually blends experience in industrial automation with modern web development. When you think about that digital shock absorber we talked about earlier, the physics-based damping, the structural stability of the needle, the statistical filtering of noise, you can really clearly see the influence of industrial automation. It's not just code. It's engineered like a physical machine, designed to tolerate chaos and deliver precise, stable outputs.
Section 4. Results and Future Relevance.
Okay, let's look at the results and why this matters going forward. This project wasn't just some academic exercise or a simple portfolio piece. The result is a fully realized, production-ready digital product. It features a dedicated landing page with strict SEO metadata, open graph integration, and web application schema markup. It's highly optimized for search engines and built to acquire real users. But more importantly, the Bkappi Tuner proves something vital about modern technology. Complex, high-performance audio processing can be executed elegantly, safely, and entirely within the user's browser. It delivers immense value by prioritizing user privacy and completely eliminating the friction of app installations.
Which brings us to our final takeaway. The Bkappi Tuner is absolutely a fantastic tool for musicians, for sure. But it's also a really powerful proof of concept for the tech industry as a whole. It leaves us with an inspiring, honestly kind of provocative question. If the web browser can now handle complex, multi-stage digital signal engineering, perfectly render 60 frames per second animations, and run entirely offline with zero data leakage, what other heavy, intrusive native apps can we replace with pure, frictionless web technologies? It's an incredibly exciting frontier for product innovation. Thank you so much for joining me on this explainer. Keep learning, and I'll see you next time.